Hello, welcome again to the online video lecture series Essentials of MATLAB. This is chapter 4 Graphics in MATLAB. It's part 2 of this chapter. So in the last lecture we have already covered 2D graphs, multiple plots and editing tools. So in this chapter we will cover the remaining part, that is the 3D graphs, surface plots and the animation. Let's first analyze what is the requirement of 3D plotting. Okay, suppose we are having a time period t and we want to plot a sine wave. So this is of the frequency 3 because 2 pi is the periodicity of the sine wave. Let's have a cosine wave also. So now we are having a cosine wave of 6 pi t. Okay, so if we want to plot x versus y, it means sine wave on the x-axis and cosine wave on the y-axis. So what will be its graph? So let's analyze. Graph of sine wave versus cosine wave is ellipse, or you can say a circle. So this is graph in 2 dimension, but actually this is not the real graph because we are analyzing this wave in 2 dimensional. That's why it's looking like a ellipse or circle, but actually if we analyze this graph in 3 dimension, then it is just some different graph. So let's analyze this thing in 3 dimension. So if you want to plot your data in 3 dimension in continuous domain, so you will be using plot 3 and you have to provide 3 variable here. Now we are having time, x axis values and the y axis values. So this is the actual graph. Actually the sine wave versus cosine wave is a helical structure. So let's rotate it in some another direction. So just click on this button so that you can rotate it in 3D. So when you will click and hold and then drag it, you can rotate it in any direction. So it is actually a helical structure. Okay, so if I move it back again into 2 dimension, so it will be looking like a circle or ellipse as we are having earlier in 2 dimension. Okay, so this was the graph in the 2 dimension, but actually it is a helical structure. You can analyze very clearly in 3 dimension. So in this way you can plot 3 dimension graphics with plot 3, stem 3, and similarly for the easy plot, that is the easy plot. So let's create some 3D surface. Actually to create a 3D surface you will be requiring a matrix because that matrix you will be representing as a surface, that is a 3D. So you will be using the command surf and mesh for 3D plots, and you can create matrices using the mesh grid also, and there are lots of another commands. If we are using mesh grid, then let's see what mesh grid commands performs. Suppose if I am writing mesh grid and if I'm writing -1 to 1, it means it will repeat this range row wise. Let's see, it's repeating -1 to 1, -1 to 1, -1 to 1. Okay, and you can also provide 2 variables here, so it will repeat first argument as the row wise and second argument as the column wise. Okay, so these are the answer. It is repeating row wise and here it is repeating column wise. Okay, so in this way by using mesh grid you can create a different structure of the matrices. So let's plot the Gaussian curve. So to plot Gaussian curve you can either use the Gaussian formula, the standard formula, or you can directly use Gaussian function, that is the f spatial. So just write f spatial, and the Gaussian is its type. Actually f spatial is a function to create the matrices for the filters. Different kinds of filters are available by default in the MATLAB. So we are using Gaussian, and this is the matrix dimension 100 by 100, and we are using variance 12. So let's enter G, and now we are having G as a matrix whose dimension is 100 by 100. Okay, so let's plot this matrices. So let's plot this matrix as a surface. To plot any matrix as a surface, just you can use surf command and just write the variable name, and here is your Gaussian curve. So you can also rotate this curve in 3 dimension. So this is basically our Gaussian curve, and you can analyze it in any direction, and it is easily visualized that when you are moving this graph, you here the two values are changing. One is azimuthal angle, az means azimuthal angle, that is in x direction if you're rotating, and next is elevation angle if you're rotating in the y direction. Okay, these are two angles you can control by the commands also, by which you will be creating some animations. So this is basically a Gaussian curve. And also you can plot lots of matrices. If you want to plot this matrix using mesh, then you will be writing mesh G. Okay, the only difference between the mesh and the surface is when you are using surface, then this structure is filled with color, but now this structure is not filled, only the lines are there. You can easily visualize only the grid lines are there, but it is not filled. So this is the only difference between the mesh and the grid. Okay, and you can also create surface for the different matrices. So let's plot a surface for the another matrix. Suppose we are having Z identity matrix. Suppose I am having identity matrix of 100 by 100. So let's see its surface. Okay, so this is basically the surface of the identity matrix, because at the diagonally it is 1. So you can easily see diagonally this matrix is 1 and otherwise it is 0, and you can easily analyze this thing that at 0 and 0 it is you can say at 1 and 1 it is 1, and similarly on the diagonal it is 1, and other than it is 0. Okay, so in this way you can define lots of matrices, and you can analyze the matrices as a surface plot. The next topic is animation. So to create an animation, let's just create again the Gaussian curve. So f special is the function to create the Gaussian matrix, and we are having 100 by 100 matrix, and the variance is 12. Okay, and let's just save this file, and we are using surf x. Okay. So now this is our graph. So when we are rotating this graph in 3 dimension, so basically two angles are changing, azimuthal and elevation. So as I told you earlier, that you can also change these angles using the command. So let's just write a command. Suppose if I am writing view, use the command to set the elevation and azimuthal angle. So first argument you will be providing here is the azimuthal angle, and this is the elevation angle. Let's just play this thing. Okay, so now this is the angle, the 100 and 250, and you can change manually and also by the command. So let's just create an animation for this thing. So the range of angle is basically 0 to 360 degree. So let's just write a loop like for I want to go from 0 to 360. Okay, and let's just write view, and here you can write I, because the azimuthal angle will change accordingly as the loop will execute. And let's fix another angle and just write an end. Okay, let's run this. Now it is already rotated 0 to 360 degree, but the speed is very fast. So to slow it down, we have to introduce a delay, and let's introduce a delay using the pause. And whatever the value you will be writing in the pause is in the seconds. So if I'm writing 0.2, it means it will pause by 0.2 seconds after each iteration. Okay, now let's run it again. Okay, now this graph is moving automatically, and it will complete its rotation up to 360 degree. Okay, suppose same case happens like when you are doing some complex computations, and your MATLAB is showing the busy status here. What if you want to stop it in between? So to stop in between, just click on the command window and press Ctrl C. So whatever the execution going on will be stopped. Okay, so now you can continue. So in this way you can create animation for the azimuthal angle as well as for the elevation angle. Okay, so let's just analyze some more animation options. So we are having a 3D graph here, 3D surface here. Now if I want to change the lighting positions, the camera and axis, then you can change. We are having a lots of GUI options. Just go to the view and camera toolbar. In this toolbar you can orbit the camera, like just click, drag and rotate. Now it's rotating. Okay, and similarly you can change any angle, like this one is for orbit scene light. You can change the light here, light parameter. Okay, and you can also change a lots of things, like you can change this axis at any moment, and similarly you can change it in any direction and create a lots of animation. Okay, so there are lots of options available here. There's a one more command for the animation, that is the comet 3, or you can use comet, but you cannot control the speed of the comet. Comet will run on its own. Suppose we are having again t as a time period, x as a sine wave, x as a sine wave, y as a cosine wave, and let's just plot comet 3 and t. Now the speed, you cannot control the speed of this animation, it will go on its own. Okay, so this was all about the animation. So we have covered all the commands that was discussed. So here completes your chapter 4. So we have discussed this thing, the plotting functions. We have discussed lots of plotting functions, as in float, 3D, 2D and discrete, continuous and symbolic. We have discussed these editing functions, GUI options, multiple plots, 3D commands and animation options. Okay. So there's a one more thing, as I have already told you that there are hundred of options or hundred of commands for the plotting. So how you will interact with that commands? So suppose if I want to plot the x in some different way, just go to the plot options. Now if you click on this button, these are all the available graphs for the x present here. Okay, these are all the available graphs present here. And if you click on all the plots, so these are the total number of plots that are present in the MATLAB, and the different types of plots. So the graphs which are highlighted is available for x, and which are non-highlighted, that are not available for the x. So let's just plot some another graph. Like if I want to plot the pie chart, so just click on the pie and it will create a pie chart for the x. So this is a pie chart for the x. So in this way you can create lots of graph, and the command for the pie chart that we have created for the x is written on the command window. So this is the command for the pie x, and you can also go to the help to explore the pie command or whatever the command you are using. Okay. So thank you very much. Here completes your part 2 and chapter 4.